Hello everybody, this is Mr. Combs and this is the second part of our applications of equations video. Couldn't fit it all in one video, so I'm here to continue talking about applications. So the next set of applications that we want to talk about, or the next type of problem that we're going to talk about, is the percent problem. And when I say percent problem in this case, what I mean is percent increase and percent decrease. So we're going to start out with an original amount. We're going to take 50% off because it's a sale, or we're going to add a 15% off. I'm sorry, a 15% tip or something like that. So that's what we're talking about. Now I think that you'll agree that in percent problems we always have an original amount and then we're going to add or subtract some percent of the original amount. That's going to give us the new amount. Okay, in our percent problems, the original amount will always be unknown, so we're always going to let a variable represent the original amount. Then we're going to add or subtract some percent of the original. Remember that we always have to change a percent to a decimal, so decimal point, and then a percent usually has 2 decimal spaces. Let me make that 2 decimal spaces. There we go. That looks better. Of means times, and then we have the original amount again, so x. And that's always going to equal the new amount, which will be given. So if you can remember this formula, x plus or minus decimal point, 2 decimal places, x equals given, then you've got it. You've got it for percent problems. Let's take a look at the first one. Jake paid $14.78, including 6% sales tax for a biography of Justin Bieber. How much did the book itself cost? Well, we're going to start this out by saying, I don't know how much the book itself costs, so that's x. If I have sales tax, then I'm adding a percent onto the original price, so plus. This is 6% sales tax, so 0.06, and then times x, so it's 6% of x, is equal to $14.78. The given. That's it. We've got our equation. I have like terms here with this is really a 1x, right? So I have like terms. 1x plus 0.06x is 1.06x, and that equals 1478. If I divide by 1.06 on both sides, then I'm going to get x is equal to 1478 divided by 1.06. Just do this on the calculator. And it looks like that it is 13.94339623, and that's the end of the decimal spaces on my calculator, but it probably will go on after that. So let's just round that to the nearest cent, so I think it's 13.94. $13.94. Alright. Let's look at the next one. It says the Browns are planning to sell their home in the West Hills. If they want to be left with $117,500 after paying 6% of the selling price to a realtor as commission, for how much should they sell the house? Well, this is obviously one of the smaller homes in the West Hills. But this works the same way. I don't know what the original price is or how much they should sell the house for. So that's x. This time I'm having to give up 6%. So x minus 0.06 of x. And after I give up 6%, I should be left with $117,500. So now I have, this is really a 1. So now I have 1 minus 0.06, so 1 minus 0.06 is 0.94. So 0.94x is equal to 117, comma 500. And if I divide by 0.94 on both sides, I have 117, 500 divided by 0.94, and that's going to give me 125,000. So how much should I sell the house for? 125,000. If when I give 6% up, I want to be left with 117,500. What do you think? All right, let's look at the next type of problems. Perimeter problems. Basically, for perimeter problems, we're looking at the perimeter of a rectangle. So we're always going to have the perimeter of some rectangle. And we're going to know something about one of the dimensions. We have a length and we have a width. So we're going to know something about one of the dimensions and we're going to know the actual perimeter. We can write one dimension in terms of the other. So if I don't know the width, I'm going to know something about the length based on the width. Okay? So that's the way we're going to get only one variable. So let's take a look at the example that we have. It says the perimeter of the cross-section or end of a 2x4 piece of lumber is 10 inches. So basically what this is saying is that a 2x4 piece of lumber, here we go, is not actually 2x4. This is not actually 2 inches, and this is not actually 4 inches. It's actually a little bit off. Okay, so we want to find the true dimensions. Well, I know that the perimeter is 10 inches. So I know the distance around is 10 inches. By the way, that's what perimeter means, distance around. I sort of take for granted sometimes that everybody knows what perimeter means, but you may not. So it means distance around. And another thing I'll say is that we find the perimeter by adding up the length plus the width plus the length plus the width. So adding up each of the sides is a way that we find the perimeter. So that's how we're going to create our equation. Alright, so I know in this example that the perimeter is 10. I also know that the length is 2 inches more than the width. So if I let the width be W, then all I have to do to find the length is to add 2 to that. So the width is W and the length is W plus 2. I can easily fill in this equation using this information. So the perimeter is 10 and the length is W plus 2 plus the width W plus another length W plus 2 plus W. There's my equation. All I have to do now is combine like terms. So 1, 2, 3, 4 W, so I have 4W plus 2 is 4 equals 10. If I subtract 4 from both sides, I'm going to have 4W is equal to 10 minus 4 is 6. And if I divide by 4, W is going to equal 1 1/2 inches. So the width is actually not 2, but it's actually 1 1/2 inches. And then all I have to do is add 2 to that to get the length. So the length is 2 plus 1 1/2, so it's 3 1/2 inches. So a 2x4 is actually a 1 1/2 by 3 1/2 instead of 2x4. Okay, let's look at the next type of problem that we want to deal with, triangle problems. Now when we look at triangle problems, basically in a triangle problem, we have a triangle, And we know that if we add the angles of a triangle up, we're going to get 180 degrees. That's all we need to know. So the first, our technique is going to be to, we have three angles always. Our technique is going to be to represent those three angles and then add them up and set them equal to 180 degrees. So you got to find a way to represent the three angles. So you want to look at the angle you know the least about. It says the second angle of a triangular parking lot is 4 times as large as the first. So I know that the second angle is something. I also know that the third angle is something. So what is it that I don't know anything about? The first angle. So I might let x equal the first angle. Okay, the second angle is 4 times as large as the first. So how do I represent 4 times as large as x? Well, 4 times x, right. So that's the second angle. And the third angle is 45 degrees less, so 45 degrees less than the sum of the other two angles. So x plus 4x minus 45. I'm going to actually combine like terms to make that 5x minus 45 to make it easier to work with. And that's the third angle. Now all I have to do is add these up and set them equal to 180. So x plus 4x plus 5x minus 45 equals 180. And now I've got my equation. So I combine like terms. X, 4x, and 5x is what? 10x minus 45 equals 180. Okay, now I want to add 45 to both sides. So I'll have 180 plus 45 is 225. So 10x equals 225. If I divide by 10, x equals 22.5. So that's the first angle. The first angle is 22.5. To get the next angle, I'm going to take 22.5 and multiply it by 4. So that's 90 degrees. And to get the next angle, I'm going to take 22.5, times it by 5, and subtract 45. So that's 67.5. And just to make sure, degrees. And just to make sure, let me add those up. 22.5 plus 90 plus 67.5. That'll be 180. So I've got it. Triangle problems. Let's also look at fixed cost, variable cost problems. In a fixed cost, variable cost problem, you're going to have a fixed cost that will be the same no matter what. So that's just going to be a constant. Then you're going to add to that some variable cost. So some cost per an item, per something. This something is always going to be your variable. That's going to equal a total. Per always means multiplication. So basically, in a fixed cost, variable cost problem, you're always going to have some number plus a number times a variable, and that's going to equal a total that's given. So basically, fixed cost, variable cost problems are problems like a catering. A caterer might have a setup fee and then so many per person that they're going to cater for, if they're catering a party. Rent a car, you might pay just a fee and then so much per mile or so much per day. So let's look at the problem that we have. A certain car rental agency charges $180 per week plus 25 cents per mile to rent a car. How many miles can you travel in 1 week for $395? So basically, since we're only dealing with 1 week and this 180 is per week, then this 180 is the fixed cost. The variable cost is 25 cents and it's per mile. So we might say 25 cents times M for mile. And that's going to equal the total we can spend, $395. So 180 plus 0.25 per mile times M is equal to $395. I have my equation, now I can solve. If I subtract 180 from both sides, I'm going to have 0.25 M is equal to 395 minus 180. That's 215. If I divide by 0.25, then M is going to equal $860. So M was the number of miles, so I can go 860 miles. What do you think? That one's not too bad. Let's look at average problems. These are the last type of problem we're going to talk about. When I look at the average of something, basically what I'm looking at is the typical value. So if I want to say, on average, students make a B in my class, then what I mean by that is I have some students who make C's or D's or F's. I have some students who make A's. But if you were to pick a number or a student randomly from all the students that I've ever had, then you would most likely get a student who has made a B. Okay? So basically it's the typical or the most likely amount that a value will be. The way that we find the average usually of a list of numbers is we take the sum of the numbers and we divide that by the amount of numbers. So let's say I have a group of 5 numbers and they add up to be 500. Well, I'm going to divide that 500 by 5, the number of numbers I have, or the amount of numbers I have. In an average problem, we're going to have to come up with ways to represent some of the numbers, some of the actual numbers that we're adding. And then we're going to divide them just by the number of, or the amount of numbers that it tells us. Okay? And set that equal to sum total. It says Max averaged 80 on his first 3 algebra exams. So I can set up an equation right now. I have something or some list of numbers that I'm going to divide by 3 because he had 3 algebra exams. And I know the total is going to be 80. So I can set that up right away. Now let's fill in the 3 scores. It says the first score was 84, so I know that's 84 plus. The second score was 6 less than the third. So basically, if I don't know anything about the third, so I might let the third be X. And the second score was 6 less than the third. So how do I represent 6 less than the third? If I take 6, no, that's backwards, right? If I take the score that he made on the third exam, X, and I subtract 6 from it, then I will have 6 less than, right? 6 less than the third score. Okay, cool. Now I have my equation. All I have to do is sort of simplify this top, and then I can start to solve. So basically I'm going to have 84 plus x is 2x minus 6 all over 3 equals 80. Now the way to get rid of this 3 in the denominator, the way to get any denominator, is just to multiply that denominator on both sides. So now I have 84 minus 2x, plus 2x minus 6 is equal to 80 times 3 is 240. Actually, 84 minus 6, I can simplify that as well. That's 78. So really what I have is 2x plus 78 equals 240. So I'm going to subtract 78. 240 subtract 78. I'm going to come up here, since I have some room up here, is 162. So I have 2x equals 162. If I divide by 2, x is going to equal 81. So that's the third score. What did he score on the second exam? See, if we just left it as 81, we wouldn't be answering the question. That's what he scored on the third exam. We want to know what he scored on the second. Well, the second score was 6 less than the third. So if I take 81 and subtract 6 from it, I get 75. So the answer to this question is 75. All right. So now I think you can go ahead and work on your homework problems dealing with applications of equations. And don't forget to email me if you have any problems. I will talk to you later.